Okay, here's what I got for answers. So for the first one, it is a sine difference of. So I got sine of pi over 3 minus pi over 12, which works out to sine of pi over 4, which is root 2 over 2. Now this second one, I may be a little bit tricky because you couldn't find it right away. And if you recall from the previous lesson, if I say that sine squared theta plus cos squared theta is equal to 1, I can subtract, in this case, cos squared theta from both sides. And that's why I get that 1 minus cos squared of some angle is equal to sine squared of that angle. So sine of 45 degrees is root 2 over 2. When you square that, you end up getting a half. So you could have also just solved that by finding out what cos squared of 45 degrees, which would be like, you could say 1 minus a half equals a half and still get the same answer. But, good for you if you figured out that 1 minus cos squared of an angle is the same thing as the sine squared of that angle. For part C, root 2 over 2 is my answer. Okay, let's go on to the next part here. And this is, maybe you're going to find this kind of cool. I like this part. It says we can use these formulas to determine the exact value of a trig ratio that is not on the unit circle. Well, actually, it is on the unit circle, but not the ones that we already know, not the ones that we've already figured out. So here's an example of a unit circle with lines for where the ones we already know. So for example, this spot here, this would be pi over 6. Here, maybe I'll make this a little bit of a, I can't make it thinner easy. So that one's pi over 6. This one over here, I'll alternate and turn it to green so it doesn't mix up, pi over 4. And then this one over here is pi over 3. For example, those are the ones we know, and all the multiples of those things as we go around. But look at the one we're asked. We're asked for sine of 7 pi over 12. So we don't know pi over 12s. We can't do that. And the other thing is it says exact value, so you just can't put it into your calculator because then it's just going to give you a decimal. So here's what we're going to do. We're going to look at for sine of pi over 12. We're going to be using, going back to the formula sheet, one of these differences. So we can either subtract two angles and then use the part on the right hand side, or we can add two angles. So here's our task. Can we figure out two different angles that we know already on the unit circle, so like the 3 that I just wrote, and when added together or subtracted together I can get sine of pi over 12. Well, perhaps easiest first thing is to say, what are those in terms of pi over 12? So pi over 6 is the same thing as 2 pi over 12. Pi over 4 is the same thing, I guess I need to multiply by 3, so that's the same thing as 3 pi over 12. And pi over 3 would be the same thing as 4 pi over 12. So which ones could we use to add together to get 7 pi over 12? This one's pretty simple. This one's pretty straightforward. I think you can see that if we add together 3 pi over 12 plus 4 pi over 12, we're going to get 7 pi over 12. So our first step is to say that sine of 7 pi over 12 is going to be the same thing as the sine of 3 pi over 12 plus 4 pi over 12. And remember, we've chosen those purposefully because we know what they are. So that's the same thing as saying the sine of 3 pi over 12 is the same thing as pi over 4 plus pi over 3. Okay, now it's time to go and check out from our formula sheet the sine of two angles added together. So I'm going to look over here. So this is the one I want, the sine of these two angles together. So it's sine cos plus cosine. Maybe sine cos plus cosine. So it's going to be, here we go, the sine cos plus cos sine, and then I'll fill these in. So it's going to be pi over 4 plus pi over 3 plus the cos of pi over 4 plus the sine of pi over 3. Okay, so why don't we do the pi over 4 ones first? So the sine of pi over 4 is root 2 over 2. The cos of pi over 4, I'm looking way over there, is also root 2 over 2. Now looking at the pi over 3. Pi over 3 again is over here. And the cos of that is going to be a half. And the sine of that is going to be root 3 over 2. Okay, now we're almost there. Equals. So I'm going to have root 2 over 4 plus root 2 plus root times root 3, that's root 6 over 4. So when I combine those two together, I'm going to get, now I can't add together root 2 plus root 6 to get root 8. It doesn't work that way. If within that square root sign there's something that is a square, I can factor out that square root, but I just gotta be comfortable with the fact that it's going to be root 2 plus root 6 all over 4, and that's going to be my final answer. Okay, so that's how we determine the exact value for sine of 7 pi over 12. That was an example with radians. On our next example here is one where we have in degrees, the 195 degrees. So we're going to start off with the same idea here. So I'm going to say, in this case, if I redraw this unit circle, and these three examples, this is 30 degrees, this is 45 degrees, and this is 60 degrees. So one thing we know is that that 45 degrees, that's the only one that ends in a 5. So we're going to have to use a 45 degrees in here. So I'm wondering, 195, if I use the 45 degrees, 195, and if I take away 45, that remains 150 degrees. So I could do like this. Equals the cos of 150 degrees plus 45 degrees. Let me think about where is 150? So 180 is here. So there is 150. And just thinking here, the cos. So for 45 degrees, if I think of these ahead of time, the sine of 45 degrees is root 2 over 2. The cos of 45 degrees is also root 2 over 2. For 150, the cos of 150 is going to be equal to, now it's negative root 3 over 2. Make sure I put that negative in there, and that the sine of 150 degrees is equal to a half. All right, so now let's go check out cos of two angles added together. So when I look at this one, the cos of two angles added together, it's this one. So it's cos minus sine. Okay, so going over here, I'm going to switch to green. It's going to be equal to cos minus sine, and it's I'll just keep the same order here. So it's 150, 45, 150, 45. You'll notice if you do 150 first and then 45, then it's going to be 150 first and then 45. Like if I'm looking here, it's always like alpha, beta, alpha, beta, alpha, beta, alpha, beta, no matter what you're doing. Sometimes the sine comes first and sometimes cos comes first, but they always do alpha and then beta. So if you just keep that same order, it's going to be fairly good for you. Okay, now let's figure this out. The cos of 150 degrees, that's the one I figured out, was negative root 3 over 2, times the cos of 45 degrees, which is root 2 over 2, minus the sine of 150, which is 1 over 2, times the sine of 45, which is root 2 over 2. Okay, let's multiply these two together. Now I have negative root 3 times root 2. So those two I can multiply together. Notice I can't, root 3 plus root 2 is not equal to root 5. But root 3 times root 2 is equal to root 6. Okay, multiplying works. So in this case, I'm going to get negative root 6 over 4 minus root 2 over 4. So what do I get as a final answer? I get negative root 6 minus root 2 all over 4. And that would be my answer. Okay. There isn't a your turn on here, but I'm just going to add one. So I'm going to put a, make one up for you. I'm going to say, here's a your turn. Can you find the exact value for the cos of pi over 12? And I'm going to give you a hint on this one. I think you're going to have to use one of the subtraction. So far we have always added, right? So you're going to have to use a subtraction. So see if you can give that a shot, and I'll come back in the next video and show you what I got for an answer.